Hey, welcome to the Lab 7. Let's get started. Is my voice clear?
Yes, we can hear. Yep.
Yeah, great. So Lab 7, it's about LoRa. Uh, Before we get started, I just want to share the next quiz from last year with you. You can have a look of the next quiz. Could be the sensing, right? So could have some quite similar question for the next quiz. So you can have a try before you go to the next quiz next week. I put it into my GitHub link. You can just download the file and have a try by yourself. And I will also try to get more quiz information and final exam questions if I can. And if this is helpful, please help us to fill in the my experience in the Moodle. That will definitely help us to improve the course. Yeah, so in here, just go to the Moodle and help us to fill in this survey. And it's very helpful for us. So if you have time, please help us to do this part. And as written, I will try to get more quiz and the final exam information for you. Is that okay? Okay, let's get back to the lab 7. So for the lab 7, it's pretty straightforward and easy. You should be able to get full marks very easily. So just imagine we have a LoRa device. We have two devices. The one is the sender, another is the receiver side. Uh, the LoRa device should be something like this kind of device. It's a very small and compact IoT device. We can use this kind of stuff to send the packets in a long range with very low energy consumption. This kind of technology is very helpful for our Internet of Things. But actually, we don't have it, right? So we just do the simulation on the MATLAB, just pretend we have a sender and receiver right now. And we do have some data to be sent. Let's say we want to send some string, a message, 4336. Now we want to send this message to the receiver side. So just like how do we use the cellular network? After we decide what kind of data do we want to send, then we need to modulate and encode it, and then we can send the signal to the receiver side. And the signal will always on listening, right? It will always keep on to receive the sender stuff. And after it detects any signal looks like a packet, then it will try to decode it and demodulate and just return to the original data. So that's how it works. So in the MATLAB, what do we need to do? Now we want to encode the message 4336. Then we can generate a signal like this. This is the spectrogram of the signal. And it should be something like this. And we need to specify where is the preamble and start frame delimiter and data part. If you had a look of the slides or the LoRa document, then you will be able to figure out which part is the preamble. For example, this one, you can see this part looks like the preamble, right? But actually the preamble usually is this part. This is the preamble. And what is this stuff in here? And if you count, in the preamble, you can see 1, 2, 3, 4, 5, 6, 7, 8, right? The preamble length is 8. And after the preamble, if you have a look of the LoRa documents, and it will be the SYNC, time synchronized. So this part is used to do the time synchronization. And after the time synchronization, we can see 1, 2, 2.5, this part. This part is the down chirp used to decode, and the length equal to 2.25, 2.25. And after this, it's all the payloads, data payloads, and the length, it's not pretty sure because it depends on the length of it, but we do have a maximum number of it. So that's the package structure of the LoRa. You can simply check the LoRa document to understand this, but like we said, the preamble used to do the detection of the LoRa packets. Oh, sorry, I lose the graph, but it's okay. You know this part is preamble. So the preamble is used to detect for the receiver side to recognize this packet is a LoRa packet. And then after that, we can do the time synchronization, and we can also have the down chirp, and then we can decode the content after the down chirp. So now you should be able to know what is SFD, right? Start frame delimiter. It contains the time synchronized and the down chirp. And after that is the data part. So just make a quick note in here, just in case you don't forgot it. So preamble is 8 chirp, and the SFB is 2 plus 2.25 chirp, and the data, we are not pretty sure about the length, so I just leave it blank. So this part is quite important. So now we just go to the MATLAB and try to do the simulation. So basically just click the link and trying to download the whole packets. So just download the whole stuff as a folder in your computer. So I have already done it. So let's say we have this one, and in here, I think maybe in your screen, maybe something like this. It's in gray color. So you need to right click it and add it to path and select it folder. Okay, this part is quite important. So just take a screenshot. This is the second part. Add it to path. So after you do this, you will be able to run the examples inside. You can see we have some examples. According to the documents, we need to run this one. We need to run this file. So in this file, we can see we have some setting for the LoRa signal, such as the preamble, right? And the payload, coding rates, and etc. You can try to play with it by changing the number. You can try to change to another number, doesn't matter. Then here, just use the original one. And the preamble, I just use the original one, which is 8. And the encode payload, this is the content we want to send. Maybe you have no idea what is this one. You just simply copy this one and paste it in your console here. Then you will be able to see it's just an array, right? From 1 to 5 will be equivalent to like this 1, 2, 3, 4, 5, and transforms 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If we do it without this transforms symbol here, it will be in another shape, right? You can see this is one digit in each row. This is one, every digit are in the same row. So they are different. So now you want to change the number inside. So try to change to 4336. Let me try to do another one, like for example, this one, 4096, and then just simply replace it. But like in your assignment, you need to do the 4336 in here, in the lab, sorry. And another thing here is the LoRa SPEC, which means show the figure spectrogram. So these two part is important. This one and this one is the key things. So you need to do some modification of this script. And then you can try to run it. You will output some symbols, and then you will generate a figure in here. So like what we did, we need to copy this spectrogram, this figure, into a report. And you also need to figure out which area, for example, this one, which area is the preamble. Let's say this area, or maybe this area is the preamble, and where's the SFD, right? You need to figure out by yourself. I have already explained it to you. You should be able to get the answer. You already know the length, right? Just count the chirps, 1, 2, 3, 4, and plus 0.25 in here. And then you can see this is the payload. Is that okay? LoRa packets. Yeah. And just give you a hint in here. Okay. And what's next? We go back to the slides. And the task 2, decode the LoRa signal. And we are going to run this script to decode the file we have generated. We already get a file generated in task 1. So if you go back to the MATLAB, you will be able to see the C file in here. You can't open it. It's the binary file. But it's okay. We can just run a script to read it. So you can see another script, load signal from file. This is the path of the file. So you don't need to change the contents. And in the setting, if you have already changed the setting in the like generated script, you also need to change it. But because we didn't change anything, just keep it over there. And we can just simply run the script without any modification. And it doesn't work. Okay. So maybe we do have some difference on the setting. Let me have a check. 9, 7. Yeah, I think we had different spreading factors. This one is 9. Just make sure they have the same value. Maybe I changed the value accidentally. Now you can see we have the content 4096, right? You can just take a screenshot and then comparing the content in here, 4096, and the checksum is 194 and 197. So the checksum is help us to validate the packet, to make sure the packet is a valid packet instead of we lose any fraction of the packet during the transmission. So I hope this one helps. This lab is quite easy. So what do you need to do? Just basically put this graph, and but do not screenshot this one, okay? You need to generate by yourself. You just need to generate your own graph and then draw something on it to specify where is the preamble, where's the SFC, and where's the header and payload. Should be something like that. Like this, you just include this kind of image in your report. And of course, the decode content. Yeah, and that's the lab 7. Just to make this video short, I will just stop in here. If you have any questions, just let me know.